Hello everyone. I think all of you might be familiar with this circuit. It's quite simple. Everyone more or less knows this. I had been trying to make it work for quite some time, and I also wanted to build some high voltage output device. And of course, there are commercially available ones like this one, which is pretty good. It's also professional. It has an electrical isolation and things like that. But there is nothing more interesting than to build it by yourself. So I built this setup, very simple setup. Before going into the circuit, let me show you the voltages that it can produce. Two general commands. It's quite noisy. The transformer at the moment is quite noisy because it's not sealed properly. So be prepared for the sound. And of course, we are dealing with very high voltages. So you must be extremely careful in reproducing it. If you do not know what I'm talking about, I would not even recommend you to even try this. It's extremely dangerous. Of course, it produces very low voltage, but still low currents, but the voltage is quite high, so be careful. So once again, it's going to be a bit noisy, so be prepared. If you have headphones, try to reduce the volume now. Let me turn on the voltage. So that's my voltage power supply. So I've set to around 3 volts. Maybe I reduce it. I start from 1.2 volts. So I start with 1.2 volts. Okay, so and it's the output is connected to my multimeter, fluke multimeter. It's AC now. So let me turn on. Okay, it's going to be noisy. Okay, that's so noisy as I expected. So that's around 200 volts for 1.1 input. Let me increase it step by step. Let's go to 1.5. Okay, that's noisy now. If I hold the transformer, it becomes less noisy. So that's around 380 for around 20 milliamps, I would say. So let's go to 2.5 volts. It's almost 640 volts or 620, 630 volts, let's say. So let's go to 3 volts and then I would stop. Okay, so around 750. I expect that it should be even higher because the multimeter is probably not fast enough to pick it up. Nevertheless, so it's around 750 volts. That's quite impressive. I'm quite happy with that. So let me turn off and go back to the circuit and my connections. I'm sorry, my table is pretty messy. The lighting is not perfect. I don't want a professional setup. But let me try to explain what I have. So that's a very simple circuit. The transistor is connected, the base is connected to the feedback of this primary side. You also have the primary winding, which is connected to the collector. So this keeps on turning on and off, which induces a voltage on the secondary side. And of course, that's depending on the frequency and also the number of turns. So in the back on the secondary, you have very high number of turns, or around 1000 turns. It's wound by very thin wire, 0.05 millimeters, like I have on my pen. And these primary, both the coils have around 4 turns, and it's just 0.5 millimeters. So this one is 0.05 millimeters and this one is 0.5 millimeters. So the base is driven by around 220 volts. You can go up to 6 volts, but I stopped around 3 because I didn't want to go at higher, generate higher voltages. I wanted to be a bit more safe. It's now driven by a power transistor 2N3055. You can play with different transistors here. It's a basic NPN transistor. Once again, be careful, the voltage is pretty high. So that's my transformer. Very simple setup. I have connected using crocodile clips and wires so that I can play with the circuit with different things. So that's the white one is actually connected to the power transistor's base through this 220 ohm resistor. I have two resistors in parallel. So the black one is the emitter connected to the negative of the power supply. That's my positive. And the collector is actually connected. The casing here of this transistor is the collector that's connected to this transistor's other side, like here. So that's the setup. So on the secondary, I have, if you have noticed, I have several pins, 5 different pins. I'm not going to show how I wound the coil. It's quite simple. All of the coils have direction clockwise. All of them are wound in the same direction. And the primary has primary and secondary has different number of turns, like I mentioned. But on the secondary, what I did was I tapped at different levels. After each 300 turns, what I did was I did some isolation with an isolation tape, like this transparent tape I have here. And after each 300 turn, I took an pin out to produce different voltages. I'll show you in a second how I do that. Maybe I can show this now and then I can show you how the transistor is. So this was the last pin for the 300 volts, 3 volts input was around 700. Let me connect this one. So be careful now that the power is turned off. So that's why I handle the pins this way. So if I connect to the 4th pin from the first, as you can see, the focusing is not perfect, but yeah, it's pretty late now and I don't own a professional setup, so that's what I can show at the moment. So that's connected to the 4th pin. Let's check the voltage once again. So last time it was around 700 something, so it's 650. Turn it off. Let me go fast. Connect it to the next pin. That's the 3rd pin from the top. So 3rd pin from the top. Let's check the voltage. That should be 450, almost 100 volts less as expected. And let me connect the first 2 pins. So that's the first 2 pins, and the voltage that you develop around 250 something, yeah, 200. Okay, that's what I expected. So the current is almost less than half a milliamp. That's pretty impressive. I'm quite happy with this setup. It's quite noisy, but now I turned it off. So let me show you the winding. I'm not going to show you the winding itself, but I think you can easily puzzle it out from this. So I always wound in this direction. So focusing is not ideal. Okay, no. So that's the primary side, as you can see here. That's the first pin out. I wound everything in clockwise direction, so it's when the pins are in this side, so everything is in the clockwise direction like that. It is going inside. So that's the center tap. I took it out, and that's the last one. So that's each 4 turns. So after 4 turns, I made the center tap. Then again 4 turns. That's the output, and that's the primary side. I did it on the top because that's easy, because you can play with the number of turns, you can play with the direction and so on. That's quite easy. And below you can see a shiny tape like this one. It's transparent, and below the primary is actually the secondary. And on the secondary side, I have isolation tape here, which is not ideal. Okay, so you can see that's the first connection. I made 300 turns, took it out, isolated with the transparent isolation tape, like I showed here. Again, 300 turns, 300 turns, 300 turns, and so on. So in the beginning I mentioned 1000 turns, so it's exactly not 300 turns. In between they were around 150 or 200 depending on how I did it. So approximately, let's say, around 1000 turns on the secondary side. So you can build it also with toroid. You can try with different transformer types. This one I found it quite comfortable because this is quite big and it's quite easy to wind. You have enough space in between. So in fact you can also wind a bit more, but I stopped around 1000 turns. So this is a very simple type. So I have here an example. So it's actually, these two are the ferrite material, a cheap material. I bought it from China, and I wound it on this bobbin. So you wind it, solder it. It's broken on this side, but so you wind it, solder it, put it on top. So put it on top, and that's it. So that's the simplest setup. My hand is also a bit dirty, but yeah. So yeah, that's basically the setup. I think I don't have to go into details about this circuit. The next step would be then, of course, one can play with the number of turns, and I plan to add a variable resistor potty here on to the base. Maybe also change the transistor, connect it to a scope, and see how one can play with the frequency and so on and so forth. It's quite impressive. I'm quite happy with this. I also tried with the BC547, a simple NPN transistor. The current consumption was lower. Of course, the output was also lower. It operated higher frequencies, I think around 10 kilohertz or so. So you can also play with that. It's a general tip. Once I have some scope measurements, maybe I add a second video. Thank you very much. If you have some questions, just drop down on the YouTube comment section. Thank you. Bye.